Waited a moment. Waited all the moments I'm willing to wait. I'm gonna wait for no more moments. Thanks,
Is
YouTube.
YouTube being difficult?
We're done. We're live. It's happened.
Okay.
Is YouTube being difficult? Man, like we shouldn't like. There is a free service that allows us to broadcast to any number of people in high resolution for free. I'll give it a second to, you know, I'll give it.
We've been hitting this weird, I don't know if it's a bug in Twitch or in OBS or where it will put you live. You'll be live. You'll stop looking at the little thing that lets you know that you're live. And then suddenly you'll stop being live, but OBS will keep telling you you're transmitting at so many kilobits per second, but you're not actually live any longer.
So is this what happened with last week's Weekly Space Hangout?
No, last week's Weekly Space Hangout was Morgan didn't click the button in the back of YouTube because I forgot to remind him he needed to click the button in the back of YouTube.
Right. He was saying that it's possible that he went and gave a fairly compelling 50-minute interview that nobody could see.
No, 15. 15.
15, that's what I mean. Yeah, 15 minutes.
Okay.
Yeah.
Yeah. He did. It's entirely true.
Yeah. Yeah.
Everything on my side was transmitting to YouTube. I forgot that YouTube requires you to click play twice.
Yes, it does. You click preview, then you click play.
Yeah.
Yes, that is what you get. Hey, everybody. I'm going to say hi to Andy Cowley, Ben Kalo, Chai Latte Nebula. Whoa, there's a Chai Latte Nebula?
Isn't that fabulous?
That's not a real thing.
It's not, but it should be. And it's a real human, and the real human is fabulous.
How do we make a real Chai Latte Nebula happen? Do we have to discover something? Is it in CosmoQuest somewhere? Can we figure this out? Let's make this real. Dan Blessing, Dean Sproul, Dusty Reichwin, Guido Bibra, Henrik Bo Anderson, Janelle Duncan, John Skirone, John Siffel, Jorn Albert, Larry Beckham, Mitzvos Golem, Rich Wilson, Side MT, the Jessica Feltz, Umu, Uncle Bill Druin, and Wayne Johnson. And Wayne and I had a chance to chat this morning. Thanks, Wayne.
Excellent.
Yeah. It's possible, can confirm that that I have a chat with every new patron. And
that's awesome.
Yeah, I want to just find out like what's going on, what do you like, what do you not like, and so I reach out to every new patron who joins over at Universe Today, and then I have spend 15 minutes just talking with them. So
I may steal that idea.
Feel free. Yeah, yeah, it's fun. All right, so this week, if you're wondering what it is that you have stumbled into, is going to be a live episode of Astronomy Cast. Does anyone have any time crunches today?
We're having massive winds, so just letting you know.
Right, so your house may,
the weather
may
here
blow away, and you're in some pain right now, right?
I am. I am a cautionary tale for something, and I'm not sure what.
You should wear boxing gloves to bed?
I don't know. So about 2 weeks ago, I woke up violently at 4 a.m. and I was just like, there's something in my eye, rub, 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 rub. Because like I woke up, so the part of your brain that's like, thou shalt not rub your eye, that is how you scratch your cornea, it didn't wake up first. And it really, really hurt a lot. And I eventually got back to sleep, and I didn't put two and two together. But that night when I went to read and discuss From Earth to the Moon on Twitch, I like had this moment of, oh, great. I'm suddenly old enough that I can't find a distance to read my phone. I must find a different device. And my eyes still kind of hurt, but I was like, meh, I hate eye doctors.
Yeah.
So then I was driving at night the next night, and I make it like 10 feet, and I'm like, all of the lights look like the diamond ring effect during a solar eclipse, but much bigger. Oh shit, what the heck is wrong with my eyeballs?
Somebody has replaced every light in your vicinity with little eclipses, or there's something wrong with your eyeball.
Yeah, and it turns out that I had scratched an oval into my eye, and the scratch, because the light isn't focusing properly, is the shape that the unfocused light takes. And it's just not healing correctly. So they put a bandage contact lens into my eye, which is near as I can tell, they came at me with a 12-inch diameter piece of clear plastic and put it into my eye.
Yeah.
I know that's an exaggeration, but that's kind of the way it feels.
Yeah.
And I'm continue to be unhappy and just want
Yeah.
to sit with my eyeball closed all the time.
Okay, so what this is leading into is, I hope fans will agree with me that literally the second you just want to go and stick drops in your eye and go somewhere dark and wait for this to end, we all get it and we all understand and we all support you. So
thank you.
So feel free at any point. You just go, okay, that's it. I'm out of here.
Okay.
Yeah. And I'll know it's starting to approach that time as you're like, your hands are just like moving towards your face and you're like, I can't scratch my eye, but I want to rub my eye.
Oh, no, it's much more a matter of like the amount of time that I blink for is getting longer and longer. Cause like there is something large and plastic in this eyeball. I want to go, no. Oh.
I don't even want to talk about it.
I'm eyeball phobic. We've discussed this in past episodes.
Yeah. Rich Wilson is proposing an eye patch. Have you considered that?
So apparently eye patches simply gather moisture and germs and lead to eye infections unless you have something that, No.
Okay.
So
could have been cool.
I agree. There is a massive team eye patch apparently out there.
Okay. Let's get, did I talk about the dark forest last week? Did we talk about it on Monday?
You need to tell us about the dark forest.
Okay.
Tell us about the dark forest.
Right,
and why is Audacity not optimized for the current version of Mac OS X? Sorry, that's a different quandary.
Okay. All right. Let's get into this week's show.
Okay. Are you ready to press record?
I am ready to press record. John Scrone is saying, are we not able to donate through YouTube live chat? No, you can't donate to Astronomy Cast through YouTube live because the account isn't big enough. So it's not approved for YouTube live donations. And
make all of your friends subscribe to us.
Yeah, there you go. Or join either or both of our Patreons. That is the greatest way to support us.
Patreon.com/astronomycast to pay Susie.
Yeah.
Starstrider for me and are you Universe Today or FCAN?
Yeah.
Universe Today.
Yeah. There you go. And then you get all kinds of other benefits. Like I'll remove all the ads from Universe Today. I will have an in-person conversation with you. It's super fun. All right, let's get into it. I'm going to press record.
I have pressed record whoa, audio is coming out of something. Okay, what did I do wrong? Oh, I set the monitor to be something loud. Hold on. Let me fix that. I'm sorry. Okay, I'm pressing record again.
I've also pressed record.
Sorry, Susie.
It's okay. She can handle it. She's a pro. Here we go. Astronomy Cast, episode 522, Ages and Origins, Part 1, The Earth. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing okay enough.
Yes. You have a scratched cornea. You are in a deeply uncomfortable time right now, and here's hoping if we have this conversation next week, you'll be in less pain.
The show will go on, however.
You are the consummate professional. And I've got nothing shameless. Well, I mean, I always have things that are shameless to self-promote, but I just wanted to sort of give a big shout out to all of the fans who nagged me to continue reading the Three-Body Problem. The first book was The Three-Body Problem. The second book is called The Dark Forest. The third book, I haven't gotten there yet. I forget what it's called. But man, the Dark Force is so good. The three body problem was fascinating. It's like written in Chinese and it's been translated, and so there's all this stuff that you don't understand, just like culture wise. And so it was definitely a slog for me. But with the second book, I can't stop reading it. It is just absolutely gripping and compelling, and it just has some really wonderful ideas. So for those of you who are like me and you read the first one, you're like, I don't understand why everyone's so excited about this book. It's kind of a mediocre argument for the Fermi paradox. Get into the second book. It's so good. I can't wait to read that and the third one. So that's all. I appreciate everybody telling me to keep going, and I'm so glad I did. That's it.
Yay.
Yay. All right.
I'm gonna shamelessly promote. He just came back from his Astro tour to Costa Rica. We are both going in June to Joshua Tree, and you're invited to come with us.
You've got till the March 26th to make a reservation. Prices have been dropped, less than $2,000 a ticket. You should totally check it out. It is a even better deal, and now's your chance. If you're worried about the price, it's far more reasonable.
So join us in the desert.
Yeah, and then I'm sure you were going to talk about your trip.
Yes. So I am also going to the desert Southwest. Sorry, there's a dog. Sorry, Susie. Sorry, Susie. Sorry, Susie. That tells me that someone in our house ordered something from Amazon, and it's arriving now.
Is it a dog barking machine?
It appears to be, but the dog appears to now be done.
Okay.
Okay. So there we go. If you can't make it in June and you'd rather see the desert in late August when things are potentially a little bit cooler, join me on a trip that departs out of Tucson, Arizona, and travels up through the Canyonlands and eventually makes it to Las Vegas, baby.
Right. Go to astrotours.co to see them all. Astro.tours, actually. That's the new URL, which is even cooler. All right. So people always want to know how old everything is. And more specifically, they want to know how we know how old everything is. Well, here at Astronomy Cast, it's our job to tell you not only what we know, but how we know what we know. And today, we will begin a series on how we know how old everything is. Go.
Okay.
You picked what, a meteorite? What was it? You were talking about like how old Earth rocks are, right?
Strombolites. So one of the great quandaries and fascinations to me that is completely outside of my normal field of study is how did life on our planet end up going from being little tiny methanogen bacteria, microbes that created methane, that may be like life that might exist on Mars, might exist on Titan, to instead being oxygen generating critters. And when did that happen? And there was recently some new research studying strombolites, which are essentially fossilized mats from bacteria. And it was pushing back the date at which it looks like oxygen started to be generated at depth in the seas. And I was like, how do they know all of these things? Where are the old rocks? And so I went down a rabbit hole. And when I go down a rabbit hole, it's usually a good topic to talk about on Astronomy Cast.
Your rabbit holes get turned into Astronomy Cast topics.
It's true.
No,
it's true.
It's the exact. It happens to me as well. I think it's real. People don't realize that I would say good half, 3/4 of the topics are just whatever we are currently incredibly curious about, and so many of the episodes have been from me, and this one is clearly from you. So
standard disclaimer: I am an astronomer, not a geophysicist, and I learned pretty much everything I know about geophysics from Emily Lakdawala, Mika McKinnon, and the internet. So kudos to all of them, and follow them on Twitter. Now, in this case, we are trying to figure out what are the various ages of different things on Earth. And there's two different ways to go about this. The first one is this thing is buried under this thing, which is buried under this thing, which is buried under this thing. And you assume that the thing that is closest to the surface is the newest, the thing that is under the most layers is the oldest. And sometimes things get tricky because the earth likes to lift things up and sometimes tilt them sideways.
Flip them over.
Yeah. But more or less, when you're dealing with what's called sedimentary rock, you assume the relative ages are based on how things are layered on top of each other. And then as you go digging through them, if you're dealing with stuff that's not too old, so you're dealing with things that have occurred within the past few thousand years to 70,000 years or so, what you can do is you can go looking for plant material, biological material, anything that might have ingested carbon as part of its growing process, and measure the ratio of carbon-14 to nitrogen-14, because carbon-14 is perfectly happy to, over time, slowly decay into nitrogen. And you can count atoms and say, okay, this is young because it's all the carbon-14 in the ratio to carbon, the other isotopes of carbon that we normally see in the air. This all makes sense. Over time, the ratios change, the amount of nitrogen goes up. And so this lets you figure out the age of things that aren't that old.
Right.
But they have to be old enough. When I was a little kid, I'm going to fess up to this, I was terrified my teachers would figure out I didn't do my homework on time by carbon dating my pencil lead. I was a weird child. Also, don't teach 8-year-olds about carbon dating.
No, do. Still. Whatever is the method that, of discipline that works best, if it's giving your child a solid understanding in science, then I think that's perfectly acceptable.
But don't give them a partial understanding that makes them terrorized that, like, CSI is going to test their homework and make sure that they turned it in on time.
Would that work? I
It
don't
did for
think
me.
it's accurate. I don't think you could carbon date a pencil accurately enough to know within a couple of days if the homework had been done on time.
Well, you can't, because the half-life of carbon is 5,730 years. And so
And it would
you
only
need
tell you when the pencil was made, not when the lead was put onto the paper.
exactly. And so yeah, it's a bit of a problem. So you can only use things for certain time ranges. So with carbon, because of its several thousand year half-life, you need to be looking at something that's old, so the decay will have had a chance to have been occurring in a reliable way, but it's not so old that pretty much all of the carbon would have gone away completely. So we're looking at
the roof beams of a Roman house.
totally valid.
Perfect.
Go for it.
Yeah, they're like 2,000 years old. That's a little over halfway through the half-life. You're laughing. Oh, no, half-life is 5,700 years.
Yes.
So, a third of the way through the half-life. Like, you can definitely know that Roman timber was old.
And there's other methods that we use as well. So
And
there's
sorry, I apologize, and I don't want to stop you on this new thing, but I think exactly how this works is pretty fascinating. And can we just take a second, like how do we know that when you start the stopwatch with a piece of wood, for example, that gets used in a Roman house, how do we know that wood started at that time?
when plants grow, they're actually sucking gases out of the air to make themselves. If you've ever tried to figure out where does a tree come up with all the materials to make its leaves, its bark, its everything else, why doesn't it like hollow out the ground beneath it as it sucks up nutrients? Well, it's because the carbon that makes up the tree is coming out of the air. And the carbon in our atmosphere has specific ratios of the different kinds of carbon atoms that it has, the different isotopes, the carbon 12, the carbon 13, the carbon 14. And of course, it has nitrogen and all these other things. And we know a brand new piece of wood that you've just gone out into your backyard and chopped off of your tree is going to have, when you shove it through the mass spectrometer, certain ratios of these atoms. So new, no longer respirating, no longer ingesting from the atmosphere wood is going to have a representative ratio of isotopes and a ratio of the master parent atom and daughter element. Now, over time, some of the carbon 14 is going to be like, see ya, I'm becoming nitrogen. I'd rather be nitrogen. And through these decay processes, that carbon 14 decreases over time and the nitrogen increases. And the carbon 12 and 13 are just sitting there going, but. And so because you see the ratio of one of the forms of carbon changing in relationship to the other types of carbon that became that chunk of wood, that bacteria, that rat, whatever it is that is biological, that respirated, that change in the carbon ratios is one side. And the other side is you just count the child elements. Now, the place that the counting of the parent and daughter atoms is most relevant is actually when we deal with a different radioisotope dating mechanism. And this is where we look at the decay of uranium into lead. Earth has radioactive materials in it. It's kind of everywhere. And so when you grab a piece of rock that isn't generally being processed, that piece of rock can tell you how old its surroundings are. This is what we refer to as an igneous rock. So we have three kinds of rock. Igneous rocks, which are formed of stuff, and they sit there going, hi, I am a mineral.
I think it's igneous.
Yes, it is. I said the name of a saint, didn't I?
Probably. So,
okay.
You know,
let me start that over.
Okay.
Thank you. Good catch. So we have three basic kinds of rock. The igneous rock is sitting there going, hi, I am a rock. I formed. This is who I am. I am happy like this. We have metamorphic rock that has probably changed over time. And when you study the ratio of stuff in metamorphic rock, it tells you when that particular rock metamorphosized, came into being versus how old that surrounding is. So the igneous rock, I said it again, the igneous rock will tell you how old the area is. And then we also have sedimentary rock, which we talked about at the beginning of the show. Right. With that igneous rock, this is where we start figuring out that the Canadian Shield, parts of Australia, Western Australia, and bits and pieces of India and Africa are the oldest places in the planet, because we look at this uranium 234 that is decaying to thorium 230. We look at other forms of uranium that are decaying into lead via a variety of different decay chains. And we literally just count up what is the ratio of uranium to lead, what is the ratio of uranium to thorium. And this tells us how old that chunk of rock is, which then reflects how old that chunk of a continent is, which is kind of awesome.
But I mean, aren't those elements, when you think about, say, the thorium, like, wasn't that formed in the supernova or colliding neutrons? Or I'm not sure how far thorium is up there. It's got to be beyond iron, though, right? So weren't they formed in the supernova? So how do you know, like, how can you get any kind of local measurements when it all just came from whenever that supernova was formed? And why can't you use it to tell you when the supernova happened?
So one of the great lies that we inadvertently tell is we will say that all of the atoms of gold in that ring you're wearing were made in a neutron star collision is the new solution. But what we failed to say is that lead in that pipe that hopefully you aren't using for drinking water may have come through the decay process of uranium and was not created in a supernova. So sometimes the elements that we're looking at, they weren't created in a supernova. Their parent atom was created in a supernova. So here we know what the background distribution of atoms is on our planet in general. We know what we should expect. And when we see a concentration of uranium atoms and lead atoms interspersed inside of a rock, that is a reflection of the parent-child atomic decay process, not some supernova.
Right. But I guess the point being that, for example, with the carbon-14 turning into nitrogen-14, you know the process that came from the air to make the tree, and then you know what the ratio was the moment the tree was formed, and then that allows you to then start the clock. Same thing with magma. If you look at a chunk of lava rock, you know what lava of that variety, what mixture of elements should be in that lava of that variety. Knowing what went into it then allows you to measure the constituents, and you can start the clock and figure out when it happened. And so for every one of these timekeepers, you need to know that starting condition. You need to know what the ratios should have been. But if you just have a blob of uranium, you don't know what the starting conditions should have been. So you have no way to know when it was created from a, like, if you just have one atom of uranium or one atom of lead, you don't know when that atom of lead was formed, because it's all just random probability.
So if you have a pure block of uranium, you know it's a baby block because decays haven't taken place. If you have a block that's pure lead, you know nothing. If you have a block that is a mixture of uranium and lead, you can generally say this used to be just uranium, but it's been hanging out for this long. And the thing is, we also use this in concert with other methods, and uranium in particular, because of all the energy involved in its decay process, does a whole bunch of really cool things. One of my favorites is what's called fission tracks. And this is where you measure the damage in like volcanic glasses and other naturally occurring glasses and minerals from when uranium-238 decays. So you will get damage, faults, things you can see in glasses and minerals that contain uranium as a result of the decays. And you count up all of these things, and that tells you how much decay has happened, and that will tell you how old the glass is. We also there's other minerals that you have the uranium-234 to thorium, you have the uranium-238 going to lead. With all of these different processes, you can count different atoms, because naturally occurring, when you have uranium, it's not going to be just a single isotope. It's going to start out just like the carbon with a variety of isotopes together. So with these multiple methods all grouped together around one species of atom in all of its isotopic varieties, it gives us multiple ways to say this is within this age range. Now, with the uranium series, you are looking again at things that are very old. So here you're looking at the hundreds of thousands of years to billions of years. But there's other ways. There's yet more that uranium is responsible for. One of the other things I didn't even know before prepping for this show that you can do with uranium is, when things get buried, either by human beings digging a hole, or in the case of my house, dogs digging a hole and dropping something into the hole and then covering it back up, or just windblown dust, sand, mudslides, whatever, when something gets buried, it will have experienced a certain amount of radio induced magnetism. Paramagnetism is the fancy word. And if there are mineral lattices, they're going to be sensitive to this radiation induced process from uranium. And this, what's called electron spin resonance, can be measured and get us a date of something between 1,000 years and 3 million years. So uranium, it creates paramagnetism that affects lattices. It creates fission processes that create fractures in glass. It just plain decays into things that you can count. And so this one atom is just responsible for so many different ways that we measure the ages of things.
And I'm sure we're going to be taking a look at uranium again as we look at some of the later shows as well. But
yes.
So, and I'm just sort of imagining, so this sort of rabbit hole. Did you reach the bottom of your rabbit hole where you were like, okay, how do they know? So can you sort of go back to that original story that you were talking about and sort of get a sense of how they knew what they knew?
So the original story was on these fossilized bacteria mats in Australia. And here they were looking at a variety of different radio dating mechanisms to get at how long had these things been buried. And they also looked at the sedimentary layers. And one of the things they didn't use that I learned about in the process of doing this that works with under the ocean in particular is we've talked about the magnetic poles of the Earth flipping before and how this can actually be seen in how lava from the Mariana Trench, from where the sea floor is splitting and oozing out lava and adding more land under the sea. That land under the sea, and now I have a Disney song.
Yeah,
stuck
me
in
too.
my head.
Get it out. Get it out.
It as it comes out locks in to the sedimentary record the alignment of the magnetic field of the Earth at the moment that it was created. And you can look at the magnetic field in these different rocks as it flips over time and say, aha, this belongs to this magnetic field era. So you can also do magnetostratigraphy, which is a fabulous word that it's a new word.
That's amazing. Right. So let me see if I understand this correctly. You've got the Earth's magnetic field flipping, and when those flips happened is fairly well known. I know they look at this with looking at ancient lava flows. They can see when the flips happen because the iron crystals are magnetized to align with the magnetic field as the lava is pouring out. Apologize to everybody who thinks I say lava wrong. I'm Canadian, different from Ignatius. And so then all you have to do is look at the alignment in these rocks, and then you just kind of compare to known times that had a similar shape of the various alignments and durations, and you can go, oh, this happened during this time period. That's mental. I can't believe that's possible. That is amazing.
It's magnetic.
It's magnetic. That's a stunning accomplishment. And so it lets you just, if you can get at the magnetic crystals of any chunk of rock, you can, and there's some kind of, I guess, time, or its orientation. Then you can start to puzzle out when this stuff formed. Wow.
It's called the polarity of the Earth's magnetic field, and yeah, it's kind of awesome. And there's so much cool stuff that scientists have somehow figured out. I mean, a lot of this stuff, I'm just like, how did you initially think to look at that? The magnetostratigraphy, actually, that one makes sense. But there are inclusions in quartz crystals. Zircons in Australia, for instance, are some of the oldest rocks around. And the Jack Hills zircons date back between 3 billion and 4 billion years ago, where our planet had survived the thing that created the moon about 4.54 billion years ago. So these things are like 500 years after the Earth came into its current mass amount. These crystals contain tiny inclusions, gas bubbles, and each little bubble reflects the Earth's conditions at a different point in time. This is the same technique that we use to figure out where in the solar system meteorites come from. Well, it's also used to figure out when in the Earth's history zircons come from. And that's just awesome that these things that we use to make jewelry are our little time machines that lock in on, well, the history of our own planet.
That's just amazing. Were there any other methods, or do you want to save this for next week?
There's one more method to mention, and this one, I have no idea if I'm saying this right, but I'm going to embrace the mispronunciation. Tephrochronology. And this is looking at how volcanic ejecta layer on top of one another, and the chemistry of the lava, and this gets used to figure out how different events may or may not be related to one another.
That's really cool. It's kind of like it's that same idea, right, of the moon, and you're counting up craters on the moon and seeing the way the craters are on top of each other. And we actually, we had a project with that on CosmoQuest.
We will again. We're just rewriting our software right now. Yeah. So stay tuned, folks.
So is there a volcano mappers coming?
Not that we currently have planned, although I would love to do that for Ceres, which is apparently covered in cryovolcanoes. Yeah. But that's a different quandary.
Yeah. But so you could do that though, right? You could have cryovolcanoes. You could one volcano would be, or the ejecta would be out there from one volcano, and then another would be over top of it, and then another would be over top of that, and you could sort of detect, like, by counting up the layers of cryovolcanic
and the other cool
ejecta.
Thing about this, suddenly I'm not hearing audio from you.
Am I not there?
Now I can hear you. Okay. The other cool thing about this particular technique is there's also the chemistry and the geographic changes that come with volcanoes. When you look at the shape of a volcano, you can say, oh, that one's super tall and still super pointy. It must be still active. As they round, as they slump, you can tell they're older and older. And it's from that slumping that takes place that you can also tell the ages of the volcanoes, especially in Ceres, where the results of the cryovolcanism taking place aren't necessarily still evident for the oldest volcanoes or even the medium old volcanoes. So it's from the shape of the volcanoes as they slump back into the surface of Ceres that we can start to say old versus new.
All right, where do we go next week?
So next week, we're going to talk about things like what I just brought up with on Ceres and work on figuring out how do we know the ages of things on other worlds. And I don't know if we'll get to it next week or if there will be a third episode, but how do we measure the ages of stars and other materials in our universe?
All the way out to the cosmic microwave background radiation.
Yep.
Amazing. I love it. All right. Now, we should thank some people.
Yes, we should. So we thank a bunch of you for being awesome, and we can't thank all of you every episode. So I'm working our way down the list of our Patreon followers. If you want to help us pay Susie, please click on over to patreon.com/astronomycast. This also pays for our server and generally just keeps us going because we can't do it without you. So special thanks to Dean, Ryan James, Dwayne Isaac, Glenn McDavid, Benjamin Davies, Paul Weller, Russell Petto, Dan Littman, Martin Dawson, Kenneth Ryan, Brian Kilby, Stephen Ludking, and Thomas Shepshrup. Thank you. Thank you. We are so grateful for everything you have done to make this show possible.
Thank you, everybody. And Pamela, we will see you next week.
Bye-bye. And I need to go put eye drops in my eyeballs.
All
But
right.
I'm going
Do you want to
pause
come
the
back, or
recording
should we wrap
first.
this up?
Can we wrap this up?
We can totally wrap this up.
Okay.
Yeah,
Thank you.
yeah.
Thank you for understanding, audience. I just want my left eyeball back. I just want my left eyeball back.
Yeah, we want you to get your left eyeball back. All right.
Okay.
Thanks, everybody. We will see all of you next week. Oh,
Bye-bye.
Jesse Christensen on Monday over on my channel, Open Space, the Aussie astronomer, planetary, exoplanetary researcher working with TESS and Kepler. It's going to be a really fun conversation, so you should join us on Monday. All right.
Okay.
See you later, everybody.
Bye-bye.